Hello and welcome back to Visual Mackenzie. Today we're going to cover Physics 2 topic from the OCR 21st Century Science Board. This is for the 2017 exams and the new AQA board I will upload after September. So today we're going to cover the electromagnetic spectrum, ionisation, the atmosphere and the ozone layer, carbon cycle, different types of signals, storage of information, light and radiation. So the electromagnetic spectrum is the energy produced and it is formed with different wavelengths. It's formed in lots of different wavelengths. So the order for the spectrum goes from gamma rays all the way through to radio waves. As it is a spectrum, the wavelength boundaries differ for each different version of light. So what we can see is a very small section you can see in the middle, and it increases and decreases as you go through. As you can see, radio waves are quite long compared to ultraviolet, which is quite small. So our gamma rays are high frequency and high energy, and the radio waves and microwaves are low frequency and low energy. Microwaves don't just heat your food up from last night, but they also make your TV work. But how do microwaves actually heat your food? So microwaves, when you press start, the magnetron, which is in the main component of the microwave, starts producing microwaves. These microwaves hit the food at the same points. So to compensate with this, the food has to rotate around. But as the microwaves hit the food, the water molecules within it start to vibrate, causing energy to be produced. But by producing radiation from a microwave, it has to have a design flaw to make sure that it does not actually harm people using it, and this is done in the mesh in front of your microwave. So going back to the main spectrum, our visible light. Visible light comes in wavelengths, and when we see light, it is always in the form of white light. This is all the wavelengths combined together. So to split up the wavelengths, what we do, we refract the light through a prism. So, the light goes through the prism, refracts at an angle, then refracts again at another angle. This light opens up the spectrum to us. This is also what forms rainbows, because as you look outside, the raindrops refract the light, opening up the whole spectrum of light. So red light is made of low energy photons even, and purple light is made of low energy photons. Ionization. So in an atom, some types of radiation are dangerous because they ionize atoms. In other words, they change atoms by knocking off electrons. Ionization causes chemical reactions which cause cell in living tissue to mutate, usually causing cancer. High doses of energy can destroy cells completely, causing radiation sickness. This takes a lot of energy, only high energy radiations like gamma, X-ray, ultraviolet can do it. So the electrons spin round until the ionization, they hit so much energy an electron is knocked off. So cells can become damaged, they can do different things. So the first one, when a cell is hit, it can force a cell to mutate and become cancerous. Number two, when a cell is hit, nothing happens. Or number three, when a cell is hit with a photon of light, it can cause the cell to die. When cells die, this is what causes sunburn, sickness and sometimes even death. The greenhouse effect is often mistaken to be bad, but it is often what keeps us alive. Photons are sent from the atmosphere and absorb some of the energy. This warms the earth and some of it is reflected, and this reflection is sent out into space. But the energy that is actually absorbed into the atmosphere through the ozone layer heats the earth. Some of this, as soon as it hits the surface of the earth, it bounces up, some is reabsorbed, some is sent out again. This process keeps the Earth warm and keeps us being able to be alive. The ozone layer is mainly formed of greenhouse gases, which is the category of gases. This is full of carbon dioxide, water vapour and little amount of methane. The carbon cycle. So we're going to follow a little story. So this is Jimmy the horse. Jimmy the horse has to breathe to stay alive. This puts our carbon dioxide into the air. As he respires, carbon dioxide is put back into the air as a waste product. And carbon dioxide is then absorbed by plants in the process of photosynthesis and can either be eaten by Jimmy again, or as he will die. Over time, as he dies, the plants will become fossils and will become fossil fuel, which is a finite source. We burn these, which is put the carbon dioxide back into the air. But if plants feed Jimmy, Jimmy can die and decomposers will decompose him down, and when they expire, carbon dioxide is put back into the air. We can call the decomposers detrophs, but mainly this is a cycle and we are affecting it by having more combustion, causing the carbon dioxide in the air to increase. By cutting down plants, the photosynthesis is decreasing. But the global warming is bad. So global warming mainly causes three things. It can cause climate change, which will mean plants will die, and ever since global warming started, we've noticed a pattern of extreme weather events such as hurricanes happening, or the sea levels rising. This is not because of melting ice caps. It's a very small amount, but the main part is, as we all know, we call it thermal expansion. Because as water heats up, it expands. As any liquid heats up, it expands, and this is what causing the ocean to rise. We can have two types of signals. Signals can either be analog or digital. These are two diagrams of how they look. As digital is either on or off, and analog can vary in its different waves. Digital signals are binaries, that means they're formed as zeros and ones, and this means interference can be removed easily. Both of them are weaker over distance, but digital can be clear over distance as the interference is less. Analog makes multiple values, so this can range from 0 up to 12, or it can be anywhere in between. And when it's amplified, so there's lots of white noise in the background. So when transferring radio waves, we can either do it two ways. So as you can see in the diagram, we cannot just launch our radio waves straight across, as the hill will cause too much interference and block the signal. So the way we compensate is some waves get refracted from the atmosphere and bounce back down. This reduces the amount of interference, allowing the distance to be further when they can travel. But often, satellites, we can transfer things using satellites. Microwaves are used to communicate with satellites as they're not absorbed by the atmosphere. This is how your mobile phones work. So the microwave is pinged up to the satellite and then is sent back down to the phone. This is the sound when we're connecting phones, or when calling our best mate. This is the sound that's connecting us. So analog signals are like talking or music. They're continually in varying amplitude and or frequency. Digital signals are either on or off, as I said before. The two main advantages are more channels can be sent down the same cable. It's called multiplexing, or better quality, because digital signals can amplify without amplifying the extra noise or white noise. As we can see in the diagrams below, this is a normal signal. It's being sent. As it's being transferred, the interference has caused this, but we can easily just refer it back to zeros and ones, which can send it back to this stage. So we can use our electromagnetic spectrum to transfer signals using carrier waves. So our signal is sent across as first of all modulated, sent through a transmitter, and then decoded. So our first one is a signal sent through a carrier wave, and then put through a modulating wave. It is transmitted and then decoded at the very end stage. Light signals can be sent what we like to call fibre optics, or optical fibres. So, we send it off in the same way we do with electromagnetic waves, but as visible light, it bounces down the cable. Back in World War II and other previous ways, we use code as signals. So Morse code is a signal that consists of short bursts and long bursts of things classed as digital, either on or off. Yeah, so modern signals can be sent through an electrical or radio signals. The way we store information. So 8 bits to 1 byte for a picture. So thanks for watching, guys. Make sure to subscribe below, give this video a big thumbs up, and my next video will be uploaded in the next couple of days.